Welcome back. Previously we have discussed about the first telescoping geometric series, then zero test for the divergence, then after we have discussed integral test. In the last video we have discussed about the comparison test and piece series test. But now we are going to discuss about the Alembert-Ratio test and the Raabe test. So first let us understand Alembert-Ratio test. Suppose you have given that the series un and that series un is non-zero for all the term n. When the limit n tends to infinite, un plus 1 divided by un. If you get the answer that is L, then 0 less or equal L less than 1, the series is convergent. If you get L greater than 1, then series is divergent. If L is equal 1, then the test is failed. That means further investigation is required. If the terms contains factorial, power raised to any number, otherwise number n raised to any constant number, so in such kind of examples you can solve using the ratio test. Let us understand first example. This is un, because this series we will solve by the ratio test. Also simply you can say Alembert ratio test. So un is there, so un plus 1, just n is replaced by n plus 1, so n plus 1 factorial. So un plus 1 divided by un, but when you put here un, so absolute value of 2 raised to n plus 1 divided by n plus 1 factorial divided by 2 raised to n into divided by n factorial. But also this can be written as what? N factorial into n plus 1. But whenever you simplify, so what you are going to get? This n factor will be the cancel out, 2 raised to n is also cancel out, so only it will be the 2. So 2 into n factorial divided by n plus 2 times 1 divided by n plus 2 times 1 divided by n plus 1. When you take the limit, so you will get the answer 0, and which is less than 1, and therefore the by Alembert ratio test the series is what? Convergent. Is the series n raised to n divided by n factorial is convergent? So here un is there. From this I'm just going to write n is replaced by n plus 1, so I will get this one. But when you simplify, so this can be written as n plus 1 raised to n into n plus 1, and n factorial is there, so n factorial into n plus 1. But n factorial n plus 1 will be the cancel out, and you will get this one. And just apply the ratio, and whenever you see this is going to be the cancel out, and now what you can take n raised to n as a common, so 1 plus 1 by n raised to n raised to n is eliminating, and you will get this one. This is the standard identity, and the answer says on the E, and E is nothing but 2.7 something, and which is greater than 1, and therefore this series will be the divergent according to the ratio test. Another question, this is 2 raised to n, so constant raised to power n, and something n raised to 3. So again this question can be solved by the on the ratio test. There is no applicable here on the direct comparison test, or in fact geometric series is also not applicable, telescoping series is not applicable. So just compare whenever you fail remaining test, so just apply the first ratio test, and definitely ratio test will help you to sort out the series is convergent or divergent. So un is there, so un plus 1 you can write, just n is replaced by n plus 1, and when you simplify limit n tends to infinite, un plus 1 divided by un, we are taking your absolute value for our simplicity. Whenever the negative quantity is there, so it will be automatically positive. So whenever you see and whenever you can apply simplification, so what you will get? 2 raised to n into 2, and also you can take n raised to cube common. But let us see, 2 raised to n into 2, n raised to cube into 1 plus 1 divided by n cube. I want here n raised to cube common, so 1 plus 1 by n raised to cube plus 1 divided by n raised to cube, and this is going to be the cancel out, so you will get this one. But when you apply the limit, so you will get only 2, which is greater than 1, and therefore according to the ratio test the series is divergent. This is another question. From this you have to write the general terms, that is numerator contains 1, 2, 3, 4, so difference is 1, so I just write n starting from 1, so first term is there, second term 2, n is equal to second term is there. But denominator contains 1 is common, so I write the first one. 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, so 2 is common, and n, so power contains 1, 2, 3, again difference is 1, so I just write n, but n is equal 1, that is 2 raised to 1, and that is we have, so this is the final un. So from this you can write un plus 1. Now limit n tends to infinite, un plus 1 divided by un. But now whenever you simplify, so what you will get? N times 2 raised to n. Because I'm just going to write here, n is there, so 2 raised to n. I'm just going to take common. So what it will be? So 1 divided by 2 raised to n plus only 2. And divide by, again I'm just going to take 2 raised to n common, so 1 plus 1 divided by 2 raised to n into n is common, so 1 plus 1 1. So from this it is clear that 2 raised to n is going to be cancelled out, n is going to be cancelled out, and this is what exactly this one. And when you apply the limiting concept, so as we know that limit n tends to infinite, 2 raised to n, that is going to be the infinite. And therefore 1 divided by 2 raised to n tends to be what exactly 0, as we assume that n very large number. And therefore 0 plus 2 divided by 0 plus 1 into 0 plus 1, so this is going to be the only 2 which is greater than 1. Therefore this, according to the Raabe test, the series is divergent. Now we see Raabe test. If series un is there and with the series with the nth term is non-zero for all the natural number, so whenever we assume that the ratio test fail, so then after you have to apply that the Raabe test. So what says Raabe test? N times whatever you have un divided by un plus 1, just take its absolute value minus 1, and if you get the answer L, then if we get the L greater than 1, then the series is convergent. L is less than 1, the series is divergent. L is equal to 1, the test is fails. But already we have seen that the ratio test, whenever we apply the ratio test, so an plus 1 divided by n, if this quantity is going to be L, and if it's less than 1, then the series is convergent. Greater than 1, then divergent, and equal to 1, that is the test failed. That is we have done. But this is when we assume that this one, so whenever we assume that as a reciprocal of this quantity, so it will be un divided by un plus 1 minus 1, then after we multiply by n. And whenever you see simplification, if you supposed to get the answer L, so L is less than, but if you get L is greater than 1, then series will be the convergent. It is differently. L is greater than, here L is less than. So it is clear that whenever you apply the Raabe test, so if you get L greater than 1, the series is convergent. L is less than 1, the series is divergent. Equal to 1, again test is failed. Again further investigation is required. So simply one note is there, ratio test failed. That means you get this one and then apply the Raabe test. So let us see first question. Is that the series convergent? So first un is there. So just you write here un plus 1, just n is replaced by n plus 1 only. And whenever you simplify, so un divided by un plus 1, so this is our un, and un plus 1, that is as a division. So 4 is to n plus 1 into n plus 1 factorial into n plus 1 factorial divided by, so 2n plus 2 factorial. But whenever you simplify this one, so this can be written as this one, and n plus 1 factorial is there, so again that can be written as n plus 1 into n factorial. N plus 1 factorial, that is n plus 1 into n factorial. But the numerator can be written as what? 2n plus 1 into 2n plus 2 into 2n factorial. But from this what you can conclude that this is n factorial is going to be the cancel out. Then after you can see 4 raised to n is also going to be cancel out, and 2n factorial is also cancel out. So you will have 2n plus 1 into 2n plus 2 divided by 4 times n plus 1 into n plus 1. Just take n common from here, and whenever you simplify, so you will get only answer that is 1, because this is 0, this is 0, again this is 0, 0. 2 into 2, 4 divided by 4, that is going to be 1. And therefore the ratio test is failed. That means we have to apply the Raabe test. So un divided by un plus 1 minus 1, let us understand this one. So un divided by un plus 1, that is we have before this one. Before this one, we have 2n plus 1 into 2n plus 2 divided by 4 times n plus 1 into n plus 1 minus 1. But when you simplify, so you will get this one. But you can observe that this is going to be the cancel out. So what you will have, minus 2n minus 2 divided by 4 times n plus 1 square. Also you can see that the n minus 2 common, so n plus 1 divided by 4 times n plus 1 square. N plus 1 is going to be cancelled out and you will have this one. But we want here n multiply with whatever we have here, un divided by un plus 1 minus 1. So what I'm just going to do, just multiply by n, and when we take the limit, so our form will be this one. But whenever I just assume that the limiting concept, so just take n common and get cancelled out and you will get this one. So final answer will be minus 1 by 2, and what is the less than 1. Therefore the series is what exactly divergent according to the Raabe test. So in this video we have discussed about the Alembert ratio test. If the Alembert ratio test failed, then after we will use Raabe test. Thank you.